Alright, ladies and gentlemen, 2.3 is about chemical reactions. You did the worksheet yesterday, and that gave you some basic knowledge of what we're looking into. So you should have seen some of these terms and words before.
Pardon the interruption. Do you have Rachel Green in class right now?
Yes, ma'am.
Did you say yes?
Yes.
Please send her to the attendance office for a moment.
She's on her way.
Thanks.
Hey, Rachel. Of course that happens. Alright. So, these guided notes. All you have to do with these guided notes is follow along. They will go in order. As Brett has already figured out, there's your very first one. So, chemical properties is the ability to produce a change in the composition of matter. Chemical properties can be observed only when the substance in the sample are changing into different substances. Two of the big ones we're going to look at today is flammability and reactivity. Alright? Yes, I'm going to set some stuff on fire.
Yay. Woo. I love fire.
Say what?
A candle?
A couple of things. But yes, some candles.
That ain't mine.
Mr. Stopper.
Yes, sir.
Can I go get one of my pencils because this ink is for some reason
Grab me a new one. Alright. Oh, I forgot something. I don't have this. I don't have a huge mess. Alright. Anyone need some more time with this slide? So, flammability. A material's ability to burn in the presence of oxygen. We've all seen this one. We all know this, right? Every time you light a fire, that's an example of flammability.
Oh my God. Have you ever tried to light a candy cane up?
Oh, what now?
A candy cane? No, I have not ever tried to light a candy cane.
I did.
Oh yeah, what happens?
It was last year on Christmas. I wanted to see what it was like.
I would think it does.
Now, if you can't see from back there, here in a little bit. If you want to move forward, you may here in a little bit. Right now, I'm just lighting the candle, so nothing's happening yet. Alright? So, don't wig out. So, flammability. Got to burn in the presence of oxygen, right? All things need oxygen to burn. Without it, nothing happens. This is a simple solution of rubbing alcohol, alright? Rubbing alcohol burn? Yes or no?
Yes.
Yes.
Yeah.
We all know that, right?
Yes.
Now. Wooden stick. Everybody watching?
Whoa.
See it?
Do it again.
Alright. So, what's going to happen if I do it a second time? Anything? Is it going to do the same thing? You think? Let's see.
No.
Why not?
Oh man, see you almost got
Is that
See, that is flammability, right? Nope. That is flammability, right?
Go do
Did
it.
that hurt you?
No.
Why you get scared?
Because I don't want to get burned, so I got away from it.
No, it just don't burn you all together now.
Yeah.
Alright, let's let that air out for a few minutes before we have anything else burning. I don't want to set off fire alarms. Alright, flammability. Something burns with oxygen. Alright? We've all seen that one before, but it's always fun to see stuff burned, right? But that is just a simple solution for rubbing alcohol. Now here's my question though. When I sprayed it in there, I held it upside down. Did you see anything in there?
Yeah.
No.
Well, kind of.
Little to nothing, right? Because it vaporized along the sides. So, even though that it was non-visible, it was still combustible within. Reactivity. The properties describe how readily a substance combines chemically with other substances. Meaning when you mix two things together, does a reaction occur? You saw this yesterday, or you read about this yesterday, when we were talking about that oxygen was more reactive than nitrogen, right? And we read about that, we looked it over a little bit. So, we've got you a short video to talk about it. Some of this kind of stuff will be similar to what we're going to see tomorrow. It may not be the exact same presentations, but it will be similar. Turn the volume for you a little.
Group 1 metals are typically stored under kerosene and mineral oil to prevent or limit the reaction with the oxygen in the air. Let's look at some of the physical properties for Group 1 metals. We'll start out with lithium. The lithium is coated at this point in time with a layer of both the oxide.
What do we know lithium normally in?
And we end up with a fairly dull black.
Batteries.
here.
Lithium batteries.
Group 1 metals tend to be
This is what's
relatively
inside the battery.
soft, and we can easily cut the metal with a knife. What we can do is we can see the shiny metallic surface underneath. If we bring in a conductivity tester, we can see
What is
that
conductivity
lithium
test?
is an excellent conductor of electricity.
Electricity to flow.
There you go. How good of a conductor it is.
If we add a piece of
If
lithium
it's a good electrical
to
conductor,
water,
it's a good
one of the things
heat
that
conductor
we
as well.
is
like
the
copper.
fact that the lithium flows. Group 1 metals are less dense than water.
That's just
We
water. You
also
put
see
it in.
that the lithium reacts very rapidly with the water. This is a single displacement reaction producing hydrogen gas and lithium hydroxide. The lithium hydroxide is very water soluble and dissolves in the water. The hydrogen gas escapes. If we trap some of the gas in a test tube, we can test that the gas is actually hydrogen by testing its flammability.
Y'all see that?
We can
Watch
test that
again.
lithium hydroxide has been produced by adding an acid-base indicator. If we add some phenolphthalein, phenolphthalein is colorless in acid and red-purple in base. We can tell that the solution is basic due to the formation of the lithium hydroxide.
He's going to do that again. He produced hydrogen gas. So watch again.
We'll go down the column and periodic table in Group 1 and look at sodium. Like the lithium, sodium is
Guys, ladies and gentlemen, sit down.
It's right there.
Sit down, everyone.
piece of sodium metal. We know that it's also coated over with an oxide coating. Group 1 metal
There.
becomes
Stand.
soft. The sodium is much easier to cut than the
Here,
lithium.
Brian.
As we cut off the oxide layer, you can see the shiny metal underneath. It's cut over very rapidly with a layer of oxide.
Ladies, stop talking.
Sodium is a metal and is an excellent conductor of electricity. If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water.
Watch carefully.
Like lithium, the sodium is less dense than water and floats. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with Group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt. The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by this single displacement reaction by trapping the gas and testing
Watch
its
your enemies.
flammability. We
Hydrogen
can
is
test
highly
the fact that we
flammable.
produce sodium hydroxide by adding phenolphthalein. Phenolphthalein turns a purple-red color due to the presence of the hydroxide ions, indicating the formation of the sodium hydroxide.
So, he's producing hydrogen gas by mixing different elements. Byproduct of what was going on. Hydrogen being highly flammable, he captured it in a test tube and then introduced the fire. What that sound you're hearing is what's commonly called a dog bark. Because hydrogen is so flammable that it reacts so violently, it produces that sound. So, physical change, quick review. When some of the process material change, but the material remains the same. We've talked about this several times already. One of our examples I keep using is the example of sharpening a pencil. So, here are some other examples for you, for your general knowledge. How do you need to move over so you can see better?
That's a
My rent
fine.
due by the end of the day. If I'm overcharged, I'm charging you rent.
I only pay $25 so I can lay on the floor. I ain't not paying no $400. No Michael B.
So I'll lay in the floor, you my $25. What's your question?
If you gonna edit this video, I think you is right. I think you gonna edit this video.
Nope.
You just, okay, you bossed up like that, okay?
What?
What?
Wait.
English?
Gotta hear it at the end.
Just stop talking.
Okay.
Alright, everybody done?
Confusing me.
Alright.
The picture. Okay.
So, chemical changes occur when a substance reacts, forms one or more new substances. Cake baking, leaves changing color in the fall, digesting your food or your lunch here in a little bit. Those are all going to be examples of a chemical change. Because you're changing one thing to another, making a new substance. Any more time? So, one of the things you learned about yesterday and you read up on were preset tapes. Alright, we're gonna look at these here in a second, alright? Got a video. I can't produce these, so I don't have the chemicals for these, so I've got to do a video about that form to give you an idea. One fair warning, this entire video is in Japanese.
En el episodio anterior vimos cómo obtener
So, read. Today we obtain precipitate through a chemical reaction.
I still wanna hear him talk.
I don't. And from the resulting products, one of them will precipitate. So, this is just pure water he's putting in there. He's going to put a caustic soda, sodium hydroxide in this first one, alright? All he's doing right now is creating a solution. This one here, he's going to put copper sulfate. Once again, nothing really happens here. All he's doing is dissolving it within the water, creating a solution. Now we've got our solutions prepared, he's going to put some of the first one into the second one. Watch what happens here. A substance is formed down at the bottom, a precipitate. That is copper hydroxide. The chemical reaction, the two form a new substance that settled down on the bottom. Kind of like you read about yesterday when you mix an acid with milk and causes the milk curds to rise to the top. So, now he's going to do another one with iron sulfate instead of copper sulfate. Alright? So, here's our new distilled water. Here's our iron sulfate. So, watch what happens when he mixes it this time. Last time we got something that looks kind of like a cloud or whatever, but similar in color, right? Watch this one.
Boy.
We had a color change, and still precipitate has formed. We're going to get a close-up here on it in just a second. Both are solid substances that are formed, but this one here had an additional color change as well. Sadly, we don't have the chemicals to do these in class together. But your precipitate is any solid that forms and separates out of a liquid mixture. Everybody good? Was there a no in there? Okay. So, yesterday you read that there is three ways to know if you've had a chemical change. Color change, which we just saw, precipitate, which you just saw, or a formation of a gas. The formation of the gas is going to be the first one that we're going to do today, alright? Together.
Fella.
Cheap matches. The other side maybe that'll work.
Man, you gotta get them matches for a quarter or something.
There it is.
So, first up, this is a paraffin candle. Read about those several times yesterday, right? What happens when paraffins burn? What is produced? Does anybody remember?
A weird substance.
Carbon dioxide, because that goes with any fire, right? And water, right? Remember we said that paraffin candles produce water vapor, right? Does everybody remember that? So, I'm going to put this jar on top of it, right? What's going to happen to the candle? What's the obvious
It's
answer?
gonna go out.
It's going to go out, because we're going to, why, Ryan?
I'm gonna cover it up.
Why? Like, give me the scientific answer.
I'm gonna cover it up. all got air.
There we go. We're going to burn up all the oxygen, convert it to carbon dioxide, so the candle's going to go out. Anything else? All right. If you can't see in the back, if you'd like to move closer here, you may. Just come up here and take a knee.
I cannot see to do it.
I know, you want to see this. I'm saying, if you can't see, come closer right now. You'll have a chance. I'm telling you to move closer right now. Stop writing if you want to see. So does anyone want to move closer? Regina, you're going to have lots of time to finish this. If you want to come move forward. I know I'm in the way. All right.
Take a knee.
Take a knee. Don't stand. Take a knee. All right. Y'all good at the back? All right. You're going to have a hard time seeing back there. Adrian, you good, sir? Or are you going to stay there?
Oh God, I was holding the camera.
Please don't lean back. Brett, don't lean back.
Oh.
All right. Everybody over there see. If you can't see, you need to be able to see the candle. Everybody ready? Watch the candle. You're going to miss it.
Bruh. What? That's clean.
So what else happens other than the candle going out?
It rolls by water.
It rose. So, this is a little bit of physics as well as chemical. We know, because we talked about it, it burned up the carbon dioxide, so that's why the candle went out. We also know that from our reading yesterday, that when you burn a candle, water vapor is produced, right? So, water vapor takes up less volume than liquid water does. What happens when you have water vapor in the air and it gets onto a cool glass surface in the summer? Does it get water on your glass in the summer when you got ice cubes in it on the outside? It condensates. Water condensated on the inside of the glass here. Water vapor takes up less area. So when it condensated, the water inside rose up. So it had to equalize the pressure within because the pressure changed. And it's trying to equalize pressure with the rest. A vacuum was formed. Alright?
It's all yellow.
Yep. I colored it yellow so you can see it.
How is top turn yellow?
So what?
Why is top turn yellow?
He
It's already
colored
yellow
it.
because water's still on top. Alright, next up.
I can't see.
Alright, we got several demos. That's what I'm saying. You got time to get all these later. Hang on, ain't nothing to see yet.
Ryan's tall self. I'm sorry.
Alright.
Can you move
So,
that? Can you move the boat?
yep, give me just a second. That's not part of it.
See if you can do that.
This
Don't do that.
is a basic experiment. Guys. Some of this you're going to have seen before. Alright? So, what happens when we mix vinegar and baking soda? Easy answer. What happens? What happens when you mix vinegar and baking soda, ladies and gentlemen?
It's bubbles.
It bubbles, right? Specifically, a production of a gas. We're going to create carbon dioxide gas with this. So, just vinegar.
We.
So it's bubbling up, releasing carbon dioxide from the baking soda. All right? I can prove this, that there's carbon dioxide inside of this jar. Carbon dioxide is heavier. Don't lean on this thing. Go back around the other side. Sorry. Yep. Carbon dioxide is heavier than oxygen. So it will actually force all the other air out of here because it's heavier, more dense. So it's going to sink to the bottom and force everything else out. Don't touch any of that, Ryan. So, and we talked about, as Ryan said a minute ago, when we introduced fire to carbon dioxide, it puts it out, right? So, watch the candle. I'm going to put out that candle from here.
Lit.
Carbon dioxide is denser than air. I trapped carbon dioxide in the glass. I poured it through, because this is hollow.
Get off of my seat.
It flowed all the way down here, forcing the air out all the way until it hit the candle. And when it introduced carbon dioxide to the candle, it forced all the oxygen away from it, putting out the candle. So, one last one for you. Alright? This will probably be the one y'all find the most entertaining.
Okay.
So,
Okay.
Alright, I gotta wait on that water to get warm, so we'll talk about this for a second. This is a hair care product.
Sorry.
This has 6% hydrogen peroxide in it, alright? Hydrogen peroxide is that same stuff you get when you move, in that brown bottle to clean out wounds, right? H2O2 is its chemical formula. In here, I have yeast. Yeast, like you would make bread with, or any of that kind of stuff. Just dry yeast, okay? Here in just a second. Watch out here for a second. Grab some. Grab these, just look along the wall. There should be a thing of dish soap. I call it dish soap. Grab it. So, Montreal's going to grab me some dish soap real quick because I forgot it in the lab. Nope. I need it to be warm water. Warm water, when it's applied to yeast, causes the yeast to activate.
What is that?
Means that it wakes it up. Yeast is actually a living organism.
Like whenever you
Simple organism, like a bacteria, but it is an organism.
whenever you put like that type of bread, like whenever you put that type of bread in the oven and it rises, like that, I'm smart.
Your trick on Montreal real quick. So, let that soak for just a second.
That's nasty.
Nurse. Fine.
Yeah.
Or like right here.
Alright. So, I've now got yeast that's been added to water, so it should wake up. Now, once he comes back with that soap right there. There we go.
Good job, Montreal.
Thank you, sir. A couple of drops of soap for dramatic effect. Yep. A couple of drops for dramatic effect. Everybody ready?
What's gonna happen?
That sounds interesting.
It's a
Whoa, it's rising. Whoa. Science.
Magic.
I'm gonna touch it.
Ew, look at it.
Can I touch it?
Nope.
No, do not.
Don't touch it.
That's
Now,
Why you wanna touch it?
if you'll look closely here, it'll actually start producing heat. It's creating an endothermic reaction. The yeast, because we have H2O2, hydrogen peroxide in there, is creating oxygen. It's releasing oxygen out, and then it's causing the water at the bottom to mix with the soap I poured in there, creating foam. This is just foam that I've added a green dye to.
So why we can't touch it?
Because it's hot. It's creating an it's hot is why you can't touch it. It's creating an endothermic reaction, creating heat, meaning it's too hot for you to touch.
It don't look like hot.
It's hot. Hit the I believe button here when I tell you this is hot.
Let me tell you.
No.
50 is hot.
I did it $5.
Doesn't like that it's outside.
And I'm telling you no. If you're going to be this way, Miss Davis, you won't go to the lab tomorrow. I'm not kidding when I say this, guys. When I tell you to do something, especially tomorrow, you need to just do it. So,
You look like slime.
yep. But that's an exothermic reaction, creating heat, releasing oxygen into the air, forcing the foam upwards. Alright? Alright. Those are my demos. Finish out your notes for the day. Let's go to lunch.
Watch out for that.
No.
Huh?
Not even a little.
Can I press the button? Can I press the button?
Oops, I'm not. Go ahead and hit the stop button for me.
Okay. The red button.